Welcome to Creative World. In this video, we will solve Chapter 2 exercise problem number 2.111. While solving this problem, we will be using Kirchoff's voltage law. According to this law, a cumulative supplied and dropped voltage across circuit elements in a closed loop is always equal to 0. We also will be using Ohm's law. According to this law, voltage across any resistance R is equal to the product of current through this resistance and the value of resistance itself. Now move towards the problem. Exercise problem number 2.111. Find the value of voltage V0 in given below figure. This is the circuit diagram of given problem. Inside this network, we have to find the value of voltage across this 5 kilo ohm resistance that are labeled as V0. So without wasting time, let's proceed towards the solution. If we focus on this network, this is a closed loop circuit and the value of voltage is required to calculate. So we will apply Kirchoff's voltage law on this closed loop to calculate the value of voltage. In order to apply Kirchoff's voltage law, we should have the value of current through the closed loop with its direction. In this case, it is given in this scenario current IS flowing through this circuit in clockwise direction. So first of all, we will mark polarity notations across these resistive elements according to the given direction of current Ix in this network. Current entering terminals are taken with positive sign while current leaving terminals are taken with negative sign. Now we have to write Kirchoff's voltage law equation for this closed loop. For that purpose, start from here. Current entering terminal is positive, so voltage across this 3 kilo ohm resistance will be taken with positive sign. Next, current entering terminal is negative, so voltage of this dependent voltage source will be taken with negative sign. The value of voltage across this dependent source is 2000 times Is. Next, current entering terminal is positive, so voltage across 5 kilo ohm resistance that is labeled as V0 will be taken with positive sign. And at the end, current entering terminal is negative, so voltage of this voltage source that are 12 volt will be taken with negative sign. Now using Ohm's law, replace these two voltage with their equations. Voltage across 3 kilo ohm resistance will be the product of current Ix and 3 kilo ohm. Similarly, voltage V0 will be equal to the product of current Is and 5 kilo ohm. The equation will become 3000 Is minus 2000 Is plus 5000 Is is equal to 12 volt. This minus 12 volt is placed on the other hand side of equal to make it positive, and these kilos are replaced with 1000. Now add 5000 and 3000 together, it will become 8000, and subtract 2000 from 8000. The equation will become 6000 Is is equal to 12. Divide on both sides with 6000. The value of current Is will be equal to 2 milliampere. Now we have the value of current through this network, so we can calculate voltage across 5 kilo ohm resistance using Ohm's law. Voltage V0 will be equal to the product of Is and 5 kilo ohm. Value of Is is 2 milliampere. Take the product of 2 milliampere and 5 kilo ohm, it will become 10 volt only. Milli will cancel out with K. So the value of voltage across this 5 kilo ohm resistance in this network is 10 volt. So this was exercise problem number 2.111. Thank you. See you again in next video.